In this video, I'm going to go over pages 34 and 35 in your packet, and that is calculating work and calculating power. When we look at this, you have to pay attention to units because you're getting into things with newtons and meters, and then you're going to get into watts, and it's going to have to be in seconds when we talk about time. So you have to start paying attention to units. Work, simply put, is force multiplied by the distance. The force is going to be in newtons, the distance is going to be in meters. And if you're not given those units, then you have to convert to those units. Now, some of these problems are going to be pretty straightforward. This first one, a book weighing 1 newton is lifted 2 meters. Well, that is the force and the distance, nice and easy. So the equation work equals force times distance. You get 1.0 newtons multiplied by 2 meters, and that will give you your answer of 2 joules. Now, there's different ways you can get the units of joules, and that's what the units are going to be for work. You can have newton meters like this one is, and every once in a while you might get a problem where instead of newton, you might have to work with kilograms and stuff like that. And remember, a newton is the amount of force it takes to make a 1 kilogram object accelerate by 1 meter per second squared. So you could end up getting with kilograms meters per second squared. Now when you multiply all of that out, a joule is the same as a newton meter. You might see it written like that. And it's also the same as kilograms meters squared per second squared, because you have this kilograms meters per second squared multiplied by meters. Right, so you have joules. It's the same as newton meters, is the same as kilograms meters per second squared. Now, like I said, that one was pretty straightforward. That was just 2 joules. For number 2, gives us the force directly. 15 newtons is used to push a box along the floor, a distance of 3 meters. So pretty straightforward again. Work is force times distance. So you have that 15 newtons multiplied by 3 meters. So you're getting that unit of newton meters. And that's going to give you 45 joules. Scroll up here. For number 3, it took 50 joules to push a chair 5 meters across the floor. With what force was the chair pushed? So now you have to pay attention to what's given to you. If it's giving you joules, that is giving you the work. 5 meters is the distance, and it's asking for force now. So if the equation is work equals force times distance, but we have to solve for force, really all you have to do is divide both sides by distance. You get force equals work divided by distance. And now you want to pay attention to units because that's going to let you know if you set it up right. You have 50 joules divided by 5 meters. Now for this, remember a joule is the same as a newton meter. So now when you think about it in terms of newton meters instead of joules, the meters part will cancel out, and what you'll be left with is newtons. So you're going to do 50 newton meters divided by 5 meters, and that's going to give you your answer of 10 newtons, which makes sense because if you're asking for force, if it's asking for force, you should expect to get newtons as your unit. So that's one more thinking about the unit will help you realize if you're doing it correctly or not. Now number 4, it gives us a force, it gives us the work, and now it's asking us to solve for distance. So we could start off with this work equals force times distance. We're solving for distance, so what you have to do is divide both sides by force. So you get work divided by force. You have 150 joules divided by 100 newtons. And what you're going to end up getting as your answer then in that case is 1.5 meters as the distance. All right, let's see. The way you can kind of think about these units, if it's joules, that's kilograms meters squared per second squared. Newton is the amount of force it takes to make a 1 kilogram object accelerate by 1 meter per second squared. So the kilograms cancel out, the second squared cancel out. That meter would be gone, and you would just cross out that squared part. So the only parts left is that meter, and that's what the units end up being. And that should be a 1.5 meters. Now, scrolling down. There we go. It took 500 newtons of force to push a car 4 meters. How much work was done? All right, so now this one's pretty straightforward. It gives us force. It gives us distance. Sometimes what happens is after you do more complicated problems and you go back to an easier one, people end up making it more complicated than it has to be. So you have the 500 newtons times the 4 meters. So now you're getting the units of Newton meters. So that will give you joules as your units, and it ends up being 2,000. A young man exerted a force of 9,000 newtons on a stalled car but was unable to move it. How much work was done? All right, well, that person is exerting a lot of force, 9,000 newtons. But the problem is the car didn't move. So the distance is 0 meters. So when you think about this equation, even though that person was using a lot of force, they were putting a lot of effort into that, since the car didn't move, no work was done. So that ends up being 0 joules. All right, so that's calculating work. Now the calculating power part, I'm going to scroll down. Power is work divided by time. Work is measured in joules. The time has to be in seconds. So when you get the units of joules per second, that is the same as a watt. So let's see what this problem is. A set of pulleys is used to lift a piano weighing 1,000 newtons. All right, well, that is force. The piano is lifted 3 meters, which is distance, and it gives us the time in seconds, so that's good. Now what we're going to work up towards, and I'm putting this off to the side because we're not given this directly, is power equals work divided by time. I am given time. That was the 60 seconds, but what I'm not given directly is the work. So what I have to do is use the equation for work, which is force times distance. The force was 1,000 newtons. The distance was 3 meters, so I'll get the units of Newton meters. So in terms of work, it was 3,000 joules. So now power I can do. It's work divided by time, so it's that 3,000 joules divided by 60 seconds. I'm getting the units of joules per second, which will be the same as a watt. So when I do 3,000 divided by 60, I get the number 50. And I'll write the word watts out so it's clear when I put a capital W. I don't mean like when I write this equation. So 50 watts. Second one, how much power is used if a force of 35 newtons? So that's the force is used to push a box a distance of 10 meters. So that's distance. And they give us the time in seconds. So we end up having to do the same thing. Because if you look back at this equation, we're given work. We're given time directly. We're not given work, so we have to figure that out. So we could do the same thing. Work equals force times distance. 35 newtons over 10 meters is giving us 350 joules of work. So now power equals work divided by time. So we take that 350 joules of work divided by the time, which is in the correct unit, 5 seconds. And we end up getting 70 watts. Now notice the difference here. This first problem, it was 1,000 newtons, and that's a lot greater force than 35 newtons. But notice it was for a shorter distance and it took a longer time. Now the second problem is only 35 newtons. The distance was longer and the time was less. And that's why we end up getting a greater power output, because it was for a greater distance, which helped the work get a little higher, right? Because it went from 35 newtons all the way up to 350 because it was over 10 meters. But the key thing here is that it was done in 5 seconds. So you're dividing by a smaller number, which gives you a bigger power output. I'm going to scroll up. Number 3, what is the power of a kitchen blender if it can perform 3,750 joules of work in 15 seconds? Now this one's really straightforward because it gave us work directly and it gave us time in the correct units. So what you're getting is 3,750 joules divided by 15 seconds. And when you do that, it's 250. And since it's joules per second, we're getting the unit of watts. Number 4, how much work is done using a 500-watt microwave? All right, well, that is the power. And it's giving us the time, but the problem is it's in minutes, and we need that in seconds. So all you do is take the 5 minutes, multiply it by 60 to get 300 seconds for the time. So the equation starts off as power equals work divided by time, but we are looking for work, so we have to multiply both sides by time. So what you get is work equals power times time. So now what I'm going to do is, instead of just writing the unit of watt, I'm going to write joules per second, because that's really what a watt is. How many joules per second are being applied. And I'm going to write the 300 seconds here. So you can see now is that the seconds will cancel out, and you'll be left with is joules, and you get 150,000 joules. For number 5, how much work is done using a 60-watt light bulb for 1 hour? So same general idea. It gives us power, the time, but now I have an hour, so I have to multiply that by 60 2 times. So that is 3,600 seconds. So I could use the same equation. Work equals power times time. I have the 60, you know what, instead of watts, I'm going to write joules per second. And I'm going to multiply that by the 3,600 seconds. So seconds will cancel out. I'll be left with joules again. So 60 times 3,600 gives us an answer of 216,000 joules. Now, when you're done a problem, what I would do is go back and make sure you're getting the right unit. I'm getting joules, which should make sense because it's asking for work. Right? So that is calculating work and power.